You can come if you find some value. If you don't find value, then I'm certainly not making you come to this discussion. So up to you. It's completely optional. But basically, I'm here learning physics with you guys as well. And I did learn it to some extent in the past, and I continue to remind myself. And the books do certainly help a lot. And also, it's like when I was actually in school, I didn't have time to read all of the books on astronomy, astrophysics, all of the little details, right? So now that I talk about these topics, I actually end up learning more. So I do appreciate the books a lot and the authors of all the books. Do you believe black hole have closed time-like curve? That is true, right? Do I believe black hole has closed time-like curve? I mean, is that the same as saying that the light does not escape a black hole? She is teaching me a lot. Thank you, XNT. Teachers do use books, so there is that. Okay, so 18.6, 18.3. This was also very interesting. I loved this section of the book. So by the way, this book is called, I'm gonna link to this book, Foundations of Astrophysics. Barbara Ryden, Bradley, and Peterson are the authors of this book. I will absolutely link it again to the live, but in this little part of the book, let me just confirm for you. So it was very, oh, here it is. Do you believe black hole? Do you know if Andromeda have any rocky planets? I don't know, actually. I know we've discovered some exoplanets. They're actually more. We actually also have a live on exoplanets, by the way. So we have a few lives on exoplanets because that's a big topic as well. But the exoplanet lives, or the exoplanet research that has been done so far, mainly shows that we have found planets that are more like Jupiter's or Neptune's than they are like Earth, or I guess rocky planets like somebody is asking. So I'm not sure if there are rocky planets in Andromeda, maybe, I don't know. So general relativity predicts the existence of singularities within event horizon. So this is the black hole singularity thing. The fact that the gravitational field becomes so high for a black hole, leading to basically a singularity. That's what this is, right? This is the classical thought about a black hole, is that there is a singularity within it. A singularity is a point of infinite density and infinite space-time curvature. So infinite density, infinite space-time curvature, in other words, that infinite gravitational field thing, right? So it's like general relativity is as a theory of gravitation, right? Where gravitation is the bending of space-time. So imagine something with so much gravitation where it's almost like it creates this point of infinite density, infinite curving of space-time, and that is a black hole, according to general theory of relativity. Now, is general relativity very happy about this singularity? Not really, but that's sort of the math of it, okay? So, however, to test the predictions of general relativity and see whether singularities really exist, you would have to enter the event horizon of a black hole. So this is where we were talking, I was mentioning how the book gives an example of somebody diving into the black hole. So we'll see. Presumably once there, you'd be able to discover the answer, but you wouldn't be able to communicate your results to the outside world. It would be the ultimate scientific tragedy, having a great result, but being unable to publish it. Lurid